Good morning, children. Children, I welcome you all to today's session of science. And in science, we are on chemistry. And today we will be discussing about carbon and its compound. Carbon is treated as a wonder element in the world of chemistry simply because of its diverse kinds of usage, right? And this chapter is entirely dedicated to carbon and its various compounds. Now, in our daily life, we may use many things. Early morning, we need soap, toothpaste, brush, bird's mug, comb, and towel, and so on. We need breakfast, in which we take milk, bread. In school, we use books, notebooks. If we continue this list, it will be very, very long, right? Now, all these things, most of these things are made up of plastics. Then there are some food items comprising of carbohydrates and proteins. Therefore, we can conclude that we may use many things in our life which are made of carbon containing compounds, right? And we learn about them in a separate branch of chemistry known as what, children? It is organic chemistry, right? We know it as organic chemistry. Organic means organisms, means the chemistry involved in organisms and in the structuring of organisms is called organic chemistry, because lots of chemical reactions occur due to which we get the form which we have, right? Okay, organic chemistry may be defined as the chemistry of the carbon compounds, right? See, this is a very important line. It may be defined as the chemistry of the carbon compounds, or those which are composed of carbon and hydrogen are called hydrocarbons, right? Those which are composed of carbon and hydrogen are called hydrocarbons. This organic compounds is the study of hydrocarbon and its hydrocarbon and their derivatives. Derivatives means those compounds which have carbon, hydrogen, and something else. It might be oxygen, nitrogen, or anything else. Like, see here, there are examples given, right? Carbonates, bicarbonates, cyanides. They are kept out of this, right? Okay. Now, carbon. The earth crust has only 0.2% of carbon in the form of mineral like carbonates, hydrogen carbonates, coal, and petroleum. The atmosphere has 0.3% of carbon dioxide, right? So there's very small amount, but then its importance is immense, and this importance is due to the characteristics of carbon atom. The first and foremost, very importantly, is called its tetravalency. That is, the valency of carbon is 4, which is evident from this electronic configuration of carbon: 1s2, 2s2, 2px1, and 2py1. Right? And when it reaches an excited state, it becomes 1s2, 2s1, 2px1, 2py1. Because see, this 2pz1 is vacant here, so one atom from 2s goes there and fits in, making it 2pz1 also. Now you will find that all these four are incomplete, right? All these four are incomplete. So that is why the valency of carbon is 4, or tetravalency. Next is ionization energy. The ionization energy of carbon atom is high, that is 1086.4 kilojoule per mole. So it is practically, it has no tendency to gain or lose electrons, and preferably it can only share electron. That is why it forms covalent bonds. Electronegativity is 2.5, so as to form a covalent bond with hydrogen, because the electronegativity of hydrogen is 2.1. So it's almost almost identical, and the difference is very less. Then it has a tetrahedral structure. Carbon atom has 4 valency, and then it forms a tetrahedral structure with hydrogen. In methane, see, CH4 is methane. You can see this structuring is called tetrahedral. This, and the bond angle is 109 degree and 28 minutes here, right? Then bonding, that is the covalent bond. In previous chapter we have studied electrovalent bond and characteristics of ionic compounds. Now, as it's a covalent bond, then it is a poor conductor of electricity with the low melting and boiling points. As you can see from this chart here, that the melting and boiling point of various compounds of carbon is low. right? So um, now G and Lewis suggested that two atoms have similar or almost similar electronegativities can achieve a stable electronic configuration by sharing electron. And this sharing, the bond formed is called covalent bond, right? And now there are many types of covalent bonds which are found. First is single covalent bond, in which only one atom, one electron is shared. Only one electron of the atom is shared. You can see it from this uh, chart here, that between hydrogen and hydrogen, it can be, see children, it can be easily carbon and hydrogen also. See, carbon has 4 electrons, 1 2 3 and 4, and hydrogen has, suppose this is the electron of hydrogen, and so there can be a sharing between the two. That is also a single bond, right? Okay. See, another example is formation of H2o molecule. See, each atom, one electron of oxygen gets shared with two single electrons of two different hydrogen atoms. So two hydrogen and one oxygen will form H2O. Like similarly for ammonia, then phosphorus trichloride and methane, right? Now there is a chance of two covalent bonds, when two electron of one atom of oxygen share with the other two electrons of another atom of oxygen, right? Then triple covalent bond in case of nitrogen. Here three electrons are shared, right? Now in hydrocarbons, you can see here, this is ethene, C2H4 is ethene, and you can see here at the center here, with between carbon and hydrogen, in this structure you can see in carbon and hydrogen there is a single bond, one electron of carbon shared with one electron of hydrogen. But among carbon and carbon there is a double bond, two electrons of one carbon is shared with two electrons of the other carbon, right? Similarly with ethine, C2H2, right? There are then, here you can see that electrons of one carbon are shared with three electrons of the other carbon. Characteristic properties of covalent bond, right? Physical state, they exist as gases or liquids under normal conditions with very few existing as soft solids. Melting point and boiling point, the covalent compound have low melting and boiling points due to weak force of interaction between the molecules. Solubility, the covalent compounds are generally insoluble in water and dissolve in non-polar solvent like benzene. Electrical conductivity, they have poor electrical conduct. Now this chart has some, shows some differences between electrovalent and covalent compounds, right? We all know in this the bond, electrovalent bond is formed by transfer of electron, here it is sharing of electron. Then in this electrovalent bond, ionization takes place when dissolved in water. Ionization does not take place in covalent bond, right? Melting and boiling points are high electrovalent. In covalent they are low. Electrovalent, they are generally solids with few liquids and gases. With covalent compounds are generally liquids and gases, right? And so on and so forth. Next, we move to another very important aspect of carbon, which is allotropes. Allotropes refers to different structural forms of carbon formed by joining of different atoms of carbon, and they contains only carbon, right? There is no hydrogen, no nothing in them. And see, these are some of the examples: crystalline, like diamond, graphite, amorphous coal, and then amorphous coal, charcoal, and lamp-black, right? See, this is the diamond structuring, and you can see the refractive index is 2.5, right, which is very high. So that is why this is the structuring of diamond, right? So due to that, it has a very sharp brilliance which is there due to total internal reflection which is occurring. Now graphite is more active than diamond, but then there is this gap here in their its lattice structure which ensures that graphite can be broken horizontally rather than vertically. Then this latest one, which is called C60 isotope Buckminster Fullerene, right? This is also a you can say crystalline structure. Then, so I think we should stop here, and I hope you enjoyed it as much as I did in making it. And until we meet again, it's a goodbye.